the reason why I want to talk about Stuxnet after almost 6 years since it was discovered is because I was binge watching documentaries on Netflix the other month, and there is a documentary about hackers and security, and it has a small part about Stuxnet in it, and it was really interesting. And then I found out that there's a book available called it's about zero-day. It's about zero-day about Stuxnet, and I read that book and
Countdown to Zero Day.
Countdown to Zero Day, yes. And I gave that book to Nick, and so you're gonna have a lot of spoilers in this topic. I'm sorry.
That's okay.
And this topic is just amazing and interesting, and there's so much around it, and so I just want to mention something that is very important, because Stuxnet has a lot of speculations around it, and also a lot of politics around it. And we're not going to talk about politics at all. We're just going to talk about the technical aspects of Stuxnet and the speculations around the technical part of it. Anyone who never heard about Stuxnet before? So, thanks everybody again. I have the slides, so I gotta say. Thanks everybody for being here today with us. A little bit about myself. My name is Dolev. I work for F5 Networks as a network and security engineer. But let's move on. So, it seems like around 2010 there was a worm that was discovered by a small firm called Virus Block Beta. Actually, it's a very small firm in Belarus. And they found out that there is this mysterious worm that is targeting ICS SCADA infrastructure, water plants, energy generation, factories, etc. And it was targeting very specific infrastructure. The reason why it was so interesting is because that virus, that worm had a lot of 0 days in it. And some of them were unknown. Obviously, there were 0 days, but some of them were actually known, but were just, let's call it that, let's say that Microsoft didn't really patch them, even though they knew about them. But Stuxnet was actually exploiting a 0 day that was used by a different worm a year before, which was just never patched by Microsoft. And based on the statistics, it seems like that worm was targeting a very specific geographical location. Around 60% of all the computers that were infected by Stuxnet were in Iran. Some of them were in Malaysia, some of them were in India. And the reason why this leaked to the internet was, it seems like there was a programming error that was introduced in one of the updates. So it was first identified by Virus Block Beta. It seems like it was discovered in 2010, but based on specific things that you see in the slide, like domain names that were registered back in 2005, we don't really think that it's in 2010, because otherwise, well, at least the planning was way before 2010. It was discovered in 2010. You will see that the malware was interacting, or at least trying to interact with command and control servers in Denmark. And like I said, the domain names were registered in 2005 by unknown source. And the first version of Stuxnet used very specific 0 days, and the way that it spread was very unique. And the later versions of Stuxnet used like 4 or 5 0 days, and it had different techniques to propagate and clone itself in the network and exploit other systems. Any questions so far? If you have any question, let me know. And the last part is that the first version was 0.5. And Stuxnet in the first version was targeting very specific things in in Iran. It was targeting, at least based on the researches that were conducted by Symantec, it was targeting PLCs, and PLCs are programming logical controllers that are attached to the employees' computers directly, but they're also attached on the other end to motors for automating electromechanical processes for uranium enrichment. And that worm was not only targeting those PLCs, it had a very strict criteria until it released the payload. It's believed that the worm was brought to the nuclear plant via an infected thumb drive, because obviously the Iranian nuclear plants in, I think it was Natanz, they're isolated. They shouldn't have internet access. So it is believed that the worm got there by either a double agent or the involvement of some secret agency. And the way that worm works is that once, for example, you plug in a thumb drive to a computer, there are a lot of criteria that have to be met in order for the payload to be released. And that means that that computer has to be connected to a PLC of a specific vendor. Actually, two vendors, one in Finland and the other one is an Iranian vendor that created those PLCs. And if those PLCs were not provided by those vendors, then Stuxnet will just not be executed. Also, once a computer meets that criteria, it only infects 3 more computers, and that's it. And the way it does that is by exploiting several 0 days related to the Microsoft Brain Spooler, Microsoft Remote Procedure Call, peer-to-peer, and also, if you remember, back in like a few years ago, there was a .link Microsoft 0 day. There was another one with the autorun.inf, if you guys remember, and the first version of Stuxnet used that autorun. It's a very old technique to have like programs executed, and the later versions of Stuxnet used the .link one. And also, it also exploited Microsoft SMB to do remote code execution and copy itself to other computers. So the final version, the version that were found in 2010, had about 4 0 days. And one of them was actually a very specific 0 day for WinCC. WinCC is a Symantec front-end software to talk to that PLC. It's like a WinForms software that you can see the pipes and everything and the valves in sort of a nice graphical way. And that's how the scientists or the engineers automate the process within the nuclear plant. And they use a specific programming language, a very unique one to those PLCs in order to automate the processes. So, and that means that the development of that malware had to be sponsored in some way. You have to have access to that hardware, otherwise you just, it's nice, it's all fun and games to develop a malware in a sandbox, in a lab environment, but we all know that real life is not really close to a lab. So in order for the malware writers to be able to actually have something working, they had to have access to PLCs. They had to have access to a nuclear plant in order to test these programs, to test these exploits. And that is one of the reasons why it is believed that behind Stuxnet there is a country with a very particular interest in sabotaging the Iranian nuclear program. So this slide is actually a little misleading because it's not 4 0 days and one application 0 day. It's one of the 0 days were known already, so they're not even 0 days. It was just Microsoft just overlooked that 0 day. They did not patch it, even though the original security researcher that found that 0 day already reported that. So the mode of operation, like I explained, is that it was looking for a Windows operating system, not Linux, not Unix, only Windows. And the software had to be Siemens. It had to be it was looking for several Siemens software actually. It was looking for the WinCC. It was also looking for the PLC provided by Siemens. And also it was looking for PLCs that were working between specific hertz. It had to be between 800 to 1000. And if it was anywhere below or above that, it wouldn't work. Like the Stuxnet wouldn't release itself. So once Stuxnet is actually, the payload is actually released, it works in different ways. One is actually manipulating the rotation speed of the motors that are connected to those PLCs. And the other one was to actually do an MITM between the PLC and the WinCC, the Windows program that the scientist is using to program those PLCs. And the way that it did that was by replacing DLLs. It was replacing DLLs that were in charge of all that process of programming the WinCC program and giving instructions to that PLC. So what it did was it changed the rotation speed in a way that it raised the level to 1,400, I think, and at that range for about 15 minutes. And then it shut itself down for 27 days. After 27 days, it continued its work by reducing the hertz to 2 megahertz. And it did that for about 15 minutes. And that way, the problem that happened due to that manipulation was that the internals of the PLCs were actually touching each other inside, and it was just causing unexpected behavior, pretty much. So Stuxnet was targeting Windows machines, not Linux. It was targeting Siemens PC7 PLCs. And anything that is not under that category, Stuxnet would just not infect. It would just ignore that. And I think the reason why these criteria are there is because they didn't want that worm to leak to the internet at all. They wanted that to only specifically do specific tasks and nothing else. And it was suspected that the worm leaked to the internet by one of the engineers taking his laptop home, connecting the laptop to the internet, and that way the worm leaked. Apparently they introduced a new version of Stuxnet in one of the updates, which caused that problem. And also the Stuxnet was updating itself on the LAN by Stuxnet on computer A was talking to Stuxnet on computer B, and they were updating each other on the software version. And if that for example, computer A had an old version, computer B would update. And it is believed that the updates were through command and control servers, even though it wasn't always like that, because not all computers had internet access at all. So there is a good chance that those updates were also introduced physically through thumb drives. And this is how it looks like. This is the WinCC program, and this is a PLC, for example. So this is what the scientist has in front of him, and the whole pipes and valves that it controls are all controlled via a very specific programming language for the PLC. So we discussed that it's infects machine through flash drives, and we discussed that it's using Windows Link, and also that the Microsoft services that it exploited.